making the cool robot motor go. In other words, how to control a servo motor using a microbit. You will need one servo motor, one microbit, one motor driver board for the microbit. You'll also need a USB to alligator clips. They go from a USB port like this and end in a red positive alligator clip and a black negative alligator clip to provide 5-volt power. You will need to plug them into a USB power bank or some other USB port so we can get 5-volt power for our servo motor. You'll also need a big old bunch of breadboard wires like these. So, here is our plan. We have a servo motor here. We're going to get 5-volt power from the USB power bank. We're going to plug the USB alligator clips into it. The black will give us our ground, our negative terminal here, and the red will go to positive. Don't mix the order of these. For the servo motor itself, the servo motor has a plug that looks like this. It has 3 connectors for it. This yellow one is the servo signal. The servo signal goes to pin 0. That's cut off there. That's annoying. That's okay. We'll fix it live. We'll fix it right now in the video. There we go. So now you can see the servo signal goes to pin 0. The red one in the middle is the positive, and that goes to the positive terminal, plus here. The brown servo wire is ground. Brown is ground. So that one needs to go either to this negative here, the black, or it can go to the other side to GND. They are the same thing. They're connected inside. Ground, negative, treat them as the same. So, that's our plan. Let's execute the plan. You'll need also a bag of servo motor parts like this. In fact, you only really need one. This is a servo motor horn, all different types, as long as you have something like this that you can pop onto the servo motor. Whoop, there you go. And then it's easy to see when it turns. So once you've done that, you've assembled the servo motor. Congratulations. Good job. Give yourself a pat on the back. Next up, get your microbit and put it in the motor driver. It'll just click in there. Now, get your USB cable, put it in your USB power bank, and find a breadboard jumper, a male breadboard wire, and just grip it with the black alligator clip here, and find another one for the red alligator clip. The colors of these wires don't matter. We're going by the color here on the wire. But the color of the breadboard wires don't matter because maybe you can't find one that's black or red. That's fine. So this is getting this bit here done. Next, loosen up on that motor driver. Just loosen it a little bit, this screw terminal here. Not so much that the screw falls out because that's annoying, but just loosen it a little bit here and here. The black negative terminal and the red positive terminal. Now, you can get the red alligator clip, whatever wire you plugged into the red alligator clip, and put it into the red terminal, the positive terminal. Get your flathead screwdriver and turn it so it's just a little bit tight. You don't have to go crazy because then you'll snap it. And then do the same for whatever plugged into the black alligator clip. Good. And then do it down just so it's a little bit tight, not too tight. Then grab another male breadboard wire and plug it into the brown part of the servo motor connector. And that is going to go into ground, GND. Then get a breadboard wire for the red wire to the servo motor. And that one needs to plug into the red terminal here. You may notice we've already plugged something into the red terminal. That's okay, it's a little bit fiddly, but if you loosen this and you're careful with it, then you can fit 2 in. Just don't tighten it too hard because then the wires will break. But yes, you can put whatever you plug into this red one, pop that in here. Next. Now we've got one more wire here. This yellow wire is the only one that's left. That is the signal that is going to control our servo motor. So plug a breadboard, male to male breadboard wire into that yellow connector and put it into P0, pin 0. Now you can visit the microbit makecode website. It's makecode.microbit.org. You can make a new project. This project will be a Python-only project. We can give it a name. I'm going to call this servo demonstration. Create. And now we can write the code to move the servo motor. You'll find the relevant instructions under advanced and pins because we're advanced kiddies doing advanced things. And if you scroll down in pins, there is one here called servo write pin. Write a value to the servo controlling the shaft. Accordingly, on a standard servo, this will set the angle of the shaft in degrees, moving the shaft to that orientation. On a continuous rotation servo, this will set the speed of the servo. Well, we don't have a continuous servo. We have a normal servo. You can drag this into our code. Cool. So this should set the angle to be 180 degrees. And if you press play, it will simulate it moving to 180 degrees. Cool. Let's see what it looks like at 0 degrees. Oh, well, there you go. That's 0 degrees. You may find that this is hard to see on your microbit. Obviously, we haven't actually put the code on the microbit for one, but also it might be easier to see if it changes angle. Then you'll see it wiggle around. So let's write code to set it to 0 degrees and then to pause. So I can drag this here this is 100 milliseconds, which is not very long. Let's wait for a whole second, which is 1,000 milliseconds. And now I can copy this code here and paste it here. But instead of 0 degrees, I want 180 degrees. And then let's wait again. Let's have a look at what this does in the simulator before we put it on our microbit. Cool, so it moves to 0. Sorry, it moves to 0, which is here, and then it moves to 180, and then that's the end of the program. Just to make it even more obvious that our program is working when we actually put it on the microbit, which is soon, don't worry, hold your horses. Let's do this forever, just in a loop of going to 0 degrees, then 180, and then 0, and then 180, and then so in a loop forever. You'll find that it is loops basic. Run code forever. Cool. So I can drag this. So I'm making a function. The function is called onForever. What happens in that function? Well, the thing I want to do is these 4 lines. So I will select them, Control X to cut them, or Command X on a Mac. I can delete this pass here. Pass means do nothing. Instead of passing, by Control V, there we go. I want to run these 4 lines. So what does this program say? It says, let's make a function. The function is called onForever. When you run this function, it does these 4 things. And then, okay, by the way, keep running that function forever and ever and ever and ever and ever in a loop. So it'll do these 4 things and then go back to the top and do them again and so on and so on and so on. So hopefully it'll move to 0 and then wait and then 180 and then back to 0, and it will take a second on each, we'll wait for a second at each of those angles. Cool. We are now ready to put this program onto our microbit. So check that it works here first, and now let's put it on our microbit. To do that, you can simply press the download button, and one of a few things will happen. Maybe it completed because you've already set it up. I have already set it up. Suppose you haven't though. Suppose, there you go, I'll just do it as though, you knew you haven't set it up with your microbit yet, you haven't paired to your microbit. When you press download, it will download a hex file. And you can drag that onto the microbit, which is not too hard to do. But you can also pair the device, then click on pair, click on the microbit up here. This is assuming it's already plugged into your computer. Then click connect. And now go download. And that way you don't have to, well, you can easily put new programs on without saving the hex file. Anyway, if you look at your microbit and you look at your servo motor, it should be wiggling just like this. Cool, have fun at the servo. Bye everyone.